We're streaming. Come on, Twitch. Yeah, there we are. We're streaming. I'll tell the world. Streaming game dev. Making spaceships work. Paste. My next door neighbors are having a party. I don't think you'll be able to hear them, but who knows. If you do, I guess you can call them and complain. Well, I have been obsessively playing Stormworks. I think I've put in 80 hours since Wednesday. So I'm a little bit tired and not really in the right zone to be programming, but we're going to shake that off and get to programming. Won't that be fun? So right now what we've got is a situation where we can assign any of the subsystems we've built to any of the systems on our ship, like so. However, what we don't have is any of the fundamental structure that will allow that to be useful in a game. So basically what we're going to need to do is create a variety of interactions that allow us to do things like use those systems or move those systems or have special abilities with those systems. And the first thing we're going to implement is the ability to move the systems to their ideal location. So for that, what we're going to need to do is have our systems have ideal locations to be in. And that's what's here, system tanks, as you can see. I don't think we want to have the system as tanks, though. I think we want that small icon stuff. So the chemical tanks are supposed to go on the engines. Let's go ahead and just create a couple more of these so that we have some stuff. And I think that we're going to want to try and remember what they were before I deleted them. It's not a big deal, but... So this would be com dishes, not com, com. And then we'll go ahead and put the com dishes icon in. And we'll make these a command module. There we go. And we'll say that if they're on command, they're worth 5. And then we'll go ahead and say large radio dishes useful for a lot of things. And then down here, we're going to go ahead and make this screens. So this will be our video screens. 5 if... Oh, no, wait, this one doesn't have any bonus like that, so we'll just take it away. We'll just say a bunch of holographic screens useful in a lot of ways. And then lastly, we're going to have terminals. And this will be 5 if support. We'll go ahead and drop our support icon in there. Name it something like electrical conduits. Electrical conduits for high power and high danger work. And we're just kind of doing whatever we feel at the moment. It doesn't really matter, right? So now when we hit play, we should have 4 subsystems that we can choose from rather than 3. And you can see that there's a couple of problems, like the icon's not getting properly updated. This icon is, and we're going to go ahead and fix that. But first, let's go ahead and replace this. It's not tanks, it's command. There we are. And what we're going to want to do is here in the prefabs for the subsystem UI, we're going to see why it isn't properly working. So we're going to drop it into the content part here. There we are. We'll cruise on over to that. There we go. And you can see that we've got a big yellow, it's not yellow at all, a big round icon. And that's here in the body. It's called Picture 1, or is it called Picture? It should be called Picture. There it is, Picture. I don't believe that it's actually called Picture down here is the deal. So I think down here it's called Icon. So basically what we've got to do is rename this Icon. And then we'll hit Apply, and then we'll delete it. We're going to have to bring it back in a little bit, though. This is a temporary deletion. There we are. Now it actually shows the correct icons. So now we can sort of get a feeling for what's going on, but you can see how the bottom description isn't proper. It's not set up right. We're actually going to create a new kind of object, which will allow us to properly describe what's going on with the power of the object in question. So to do that, we're going to need a new kind of class, and that's going to be, let's go ahead and create a new category here. Ship functionality. We're going to create a new class called subsystem ability. Open that up. I bet we need an update. Do we need an update? Gonna tell me we need an update? No, for once it didn't tell me. That's shocking because it's been almost a week since I opened this. All right, so the subsystem ability is going to contain a lot of abstract elements. This is an interface, but since Unity barfs on interfaces, we're making it a class. So we'll just go ahead and put in some functions. Public virtual string desk. So if we make it, I guess we can just make it a string. We don't need to make that a virtual. So basically what we're doing is we're making it so that it has a description. And what we're also going to want to do is make it so it has a system. Public, we're going to need the UI, I think. Sprite, what's it called? Category, subsystem, system. There we are. So what we've got now is, why is this barfing? Is it not a sprite? Is it a sprite? It's a sprite. That's fine. And what we're going to want to do is just use this to actually define the abilities. But the thing is that this doesn't actually contain any ability in it. So what we're going to need to do is have it function with an ability that can be overridden. Public virtual void activate. And then we're going to pass it a ship. Now the only problem is we don't have anything like a ship. So debug.log, no behavior defined for default subsystem ability. Now we don't actually have something called ship. For now we're just going to switch it over to a game object. Later on we'll create a ship object. I could do that now, a ship class. I could do that now, but why? It's no hurry. So now what we've got is the ability for us to override whatever subsystem ability we have. So right now we've got these custom values. We're going to replace that with subsystem abilities. So let's go ahead and create a new C# called a ability, subsystem ability. So here's the difficulty. When you're doing things like this, how do you name them? And one of the ways you can fix that is to put them inside of a namespace, and that's what we're going to do. So this is going to be a special with class. Subsystem specialty. Open that up. Going to put it in namespace subsystem. Nope. There we go. And now that it's in the subsystem namespace, we won't have to worry about it. Now this is called subsystem specialty, not because it is a subsystem specialty, but because it's a subsystem specialty about being a subsystem specialty. That's obnoxious. Basically, this means that we're very good at a specific kind of subsystem. So public int value, and we'll just make that 5 for default. Now the problem is that we actually have this activate. There are several places where it activates, and one of those is going to be when we get a value, public virtual int value, and then we're going to pass it our subsystem. So ship subsystem base value, base system, subsystem. And then we're also going to need to know what the ship system that we're inside of is. So ship system, host system. I don't believe we even have a ship system. Yeah, we're going to have to build that. So we're going to go and build that now so we don't forget. We'll just rename this to ship subsystems. Hello, there we are. Down here in ship editing, we don't have any of that stuff, so we're going to have a new, no, not in helpers. Here we are. Ship functionality. Drop ship subsystems into that. It's going to end up barfing our editor, but that's fine. We're going to need a ship. We're going to need a... Did that not work? There we are. We're going to need a system. So we're going to take this system and we're going to put it in a namespace because otherwise it's ridiculous. Namespace ship. There we go. And then we're going to also need a subsystem that's in this same namespace. Currently we do have a subsystem, but it's not in the namespace that we need. So we're just going to drop this over into ship functionality, pull it up, and put it in the namespace. The only problem is that when you do stuff like this, it kind of barfs in a weird way, and that's because there is an object called system. There's a class called system in ship. So if we take this and we drop it outside of the namespace, it might work. But otherwise what we can do is we can just not say it's called system because that is not a very good name for it, as it turns out. So we're going to call it ship system anyway, even though ship system is redundant because it's inside the namespace ship. And because of that, we might as well keep this ship subsystem, even though it's inside of the namespace ship. You know what? I don't like that, though. Let's go ahead and rename the ship subsystem so that it's just a subsystem, because that's not going to end up colliding with anything. We're going to call that like so. I guess we want to rename it rather than... There we go. We'll just save that, and we're going to have to rename the file to subsystem. I think that there's a way to do that automatically, but I can never remember what order it's in. All right, so now everything should be working. We do have to program all this stuff, though, so let's get to work. The namespace global already contains a definition for ship. That's because this needs to go inside of the namespace ship. Now, there is some risk to having, ship.ship. Not risk, but there's potential confusion there, which is not a great idea. But we're going to go ahead and see how far we get before it explodes. Anyway, we're going to want a list of subsystems, systems. There we go. We're also going to need public int size equals 1. Size is going to determine which subsystems you can plug into your systems. Right now we're working with size 1. Every size is a next range up. So size 1 ships can have subsystems between 1 and 5. Size 2 ships, their subsystems are like between 5 and 10, and then there's between 10 and 20, and then 20 and 50, so on and so forth. That way you'll have a steady progress. But keep in mind that low values are also useful, because a low value means that you're nimble, you get missed, you can slip under the radar, you're very accurate. So when you have a low value, you can really end up performing well, and that's why you're going to it's not just going to be the bigger ship the better. You're going to want big ships and small ships, and maybe small ships inside big ships. Should be fun. Public string disk. Right. So we've got a list of systems, but we don't have a list of these systems don't actually have any functionality in them yet. So inside the list of systems, we're going to want a list of subsystems. Like so. Now, until now, what we've been doing is we've been using the UI very aggressively. There are UI classes associated with these, and they display arbitrarily. So right down here, we've got these subsystems, right? And these are cached subsystems. They're prefabs. They're not prefabs yet, but they will be. And what that means is that when we hit play, well, I can't hit play yet. Let me fix this, and then we'll hit play. Anything else? Oh, this is not. All right, there we are. So now when we hit play, what we've got is a UI and data separation. This is the UI element. And you can see how this is just a clone of a simple prefab over and over and over. And what it does is it links to the specific subsystem. But the specific subsystem does not have a presence. It does not know that it's in this list. It does not know that it's on the ship when it's added to the ship. And therefore, the subsystem is strictly a data class that never gets modified. And because of that, what we need to do is keep that in mind and make sure that the rest of our interface doesn't screw that up. So for that, we're going to go ahead and add that to the description of the subsystem so that we don't forget it. Ship subsystems are a pure abstract, pure template class. They are never instantiated or customized. Therefore, therefore, there is no way to ask them what system they're on because they don't know. I don't know why hitting enter makes it go exclamation point dash dash. That's pretty special there, Visual Studio Code. All right, so let's see here. We don't need this update. Kaboom, you're gone. Don't need this open, close it. So what we need to do is the ship systems have to keep track of what subsystems are on, but we're also going to need them to understand what they are. So public string desk, that's not how you spell string, that's public string. There we are. We're also going to need the UI so that we can give them a sprite, public sprite icon. There we go. And what we're going to do is we're going to use these system UIs. Come on, these here. There we are. These have the system UI on them somewhere. There it is, ship system UI. So what we're going to want to do is we have to decide exactly how we're going to end up making this work because the ship systems are going to need to be instantiated, which means that we should probably put them inside of the ship itself rather than inside of the ship UI. So for that, we've got the ship. Here it is. It's called the pufferfish. And we've got engine, support, and command. These are compounders. And what they're going to be is they're going to be compounders and ship systems. So we're just going to drop the ship systems onto each of those. And we can do that by selecting all three and then dropping ship system onto the end. And that'll add it to all three of them. Now the name will be the same, but we have to customize their icon and their description. So here's sprites. This is engines. This is support. And this is command. I'll go ahead and say where the captain lives. And these are all things we can just change later. It's no biggie. And this will be shields and science and stuff. And then up here, this will be makes ya go. So now what we've got is a ship system UI element here, which needs to be able to point to the ship system in question. Now, the only problem with that is that the ship system in question right now is bound manually. It's all set up manually. So we're going to need to, I guess we can do it manually for a while, but we're going to need to eventually fix that. One of the other problems we've got is that we are actually directly addressing the compounder. We don't want to do that. The compounder is a 3D ship object. It doesn't have anything to do with the UI. We just did that because we weren't thinking very straight. And by we, I mean me. I don't think this was your responsibility. So here you can see the compounder. See? What we're going to do is we're going to take this and we're going to add it to the ship system. And in order for this to work, we're going to need to have the compounder linked to from this ship system. So public compounder compounder. And what we'll do is we will actually make that an underscore, and then we'll have a public compounder get if not compounder, then compounder equals get component compounder. Return compounder. There we are. Little quick way to do it. Now the reason that I'm using public for this is so that I can set it if I feel like setting it. If it was protected, I would have to do like debug crap, and that would be annoying. So we're not doing this to protect the compounder variable from later access. We're doing this just so that it'll automatically set itself up, rather than having to automatically set it up in like start or something. So down here in compound, what we've got is a subsystem UI list that's getting set up. So that's not what we want. What we want to do is we actually want to go through the subsystems. And when we ask it for its value, it's the exact same setup. It's the same thing. But the only problem with this is that we aren't currently adding the subsystems to the ship system. We're adding the subsystem UI to the ship system UI. So over here, we don't need this anymore. We'll just delete it. Over here, what we're going to need to do is change this from a compounder to a ship system. There we are. And we're going to want to add in some of the ship system variables, these, so that we can reference them directly. The only problem with this setup is that we're not checking to make sure that there is a system. So if not system, return no system. And we also aren't using the ship namespace. Now we could either add this to the ship namespace, or we can just use ship. I don't know which one's better, so we'll do it that way. If not system, return null. There we are. Now we've got a bulletproof way to get the description and the icon, regardless of whether or not we know what system we're working with. And so now what we're going to do is down here, when we are calling for the compounder, what we're going to end up doing is asking it for the system position instead. And over here in the ship system, we're going to get the position in the same way that we just set it up over there. Public vector3 pause, return compounder.pause. Oh, it has to be a get. There we are. And now everything should work okay, with the only problem being that we're currently doing the wrong thing here because we are adding subsystems to ourselves. What we actually want to do is add the subsystems to the ship. So right now we've got this variable named subsystem. Just for the sake of clarity, we're going to rename it subsystem UI. And again here, because that's a UI, it's not the actual subsystem. So what we're going to do is we're going to have to add that ship subsystem to the system. System.add subsystem UI.system subsystem. There we are. And that's something that doesn't currently exist. We'll make it exist. We're also going to do system.remove subsystem UI.subsystem. And so over here in the ship system, we're going to need an add and a remove. Public void add subsystem subsystem. And same thing with remove. We'll just say subsystems dot add subsystem, and of course the opposite, subsystems dot remove subsystem. But we also have the responsibility to make the compounder function. So compounder dot compound. There we are, and now that should all work again. The only question is, all we have to do is wire it up and then test it. And we have to wire it up because we've disconnected the ship system UIs from the ship. Later on, we will make these automatically spawn in the exact same way that we do with the subsystems, but for now we'll just do it manually. So that's engines. No, that was support, my bad. Support, engines, and command. We're also going to want to make it autofill the taglines here. Now it automatically autofills some of them. So if we take a look at the system, we've got this name and this desk. We don't have an icon, but we do have name and desk, so that'll work fine for now. We'll add an icon later once we make it into a prefab. There's no reason to do something 4 times. And so you can see that we now have 4 different, oh, there it is. We now have 4 different objects. 3 different objects that have automatically been filled. We're going to just go ahead and check and see if they work. You can see how it's electrical conduits 3. It's a little bit crowded. We might have to polish that a little bit. So it works, seems to work exactly as well as it did before. If we take a look at the engines, hold on, we're not compounding. Sorry, it looks like we're not actually compounding them. So let's go ahead and highlight the engines and see where the break is. If we take a look at the subsystems here, they're empty. There's no compounder, but it should automatically find the compounder. Yeah, see? So when we drop something into the engines, it does add them, but then it doesn't compound because I forgot to tell it to compound. Sorry. Compounder.compound feels all nice and good, except for the small fact that it does not understand that there's been a change to the ship system. So when we do that, we have to pass it all the values that we're going to need. And unfortunately, I just deleted the function for doing that out of the ship system UI because it was here. If we undo some of our changes, we can copy them and then redo our changes. It's this compound function we need to track down. I shouldn't have just deleted it. There it is. Copy that and then redo all that shit. Hooray for advanced programming. I remember when I was a kid, that would have blown my mind. Public void compound. Oh, I've already got it. Let's just delete the outer. Oh wait, I've already got it. It's right up there. I already did it right. I just forgot to call it. So I was thinking, I just forgot that I was thinking. There we are. Better. Now let's try it. Yep, there we go. We're compounding correctly. Everything's working, and if we take the chemical tanks off, you can see that they come off, electric conduits off, come off. Great. So now everything's working, but what we need to do is set up our ship to understand the new subsystem functionalities. Here they are. So for these chemical tanks, we're going to want to drop on a subsystem specialty here. And the only problem with this subsystem specialty is that it just takes a value, which is a little strange. I don't think I remember it telling it to just take a value. Oh, because it's descending from mono behavior. It needs to descend from subsystem ability. There we are. There we go. So with this in mind, we can say description system value. What we're going to do is we're going to override the description here. Public new description. And then we're going to do it as a getter and a setter. Now in the other one, we don't, I don't know if this is going to work. We're going to try it and see whether it works. So return value plus on plus and then system dot name. And let's see if this works. It might just barf because I'm overriding something with a different type of something. Well, I don't know whether it's working or not, but let's give it a shot. Let's go ahead and drop in a system, which is going to be engineering. And we'll see whether or not that works. Now, the only thing is that when we are creating these potential subsystems, we don't currently have a space for the subsystem specialty. So what we're going to need to do is this power here is actually the subsystem ability. So over here, when we ask for power, we're actually going to get the subsystem ability. So we do not have a current list of those subsystem abilities, so we're going to go ahead and create them. Are we not in Ship? We are in ship. Oh, we're in not inside subsystems. Hold on. There we are. List subsystem. That's inside the brackets. There we are. Ability. Abilities. And then we're going to go ahead and say public list subsystem ability. Abilities. Get. If abilities.length, that count, equals 0. Abilities equals get components. Subsystem ability. Return abilities. What's up with this? Oh, it's sorry. There we go. So now what we've got is a setup where that works. And from here, what we're going to do is we're going to go through for each subsystem ability s in abilities. String pow equals null. Pow plus equals s dot desk plus space. If pow equals nothing, then I guess we should just say if subsystem ability. If abilities dot count length, my bad, equals 0, return no abilities. Return pow. All right, so now what should happen is it should automatically work out. We're going to just check and see whether the override is working by adding in some garbage there. So if we take a look at the chemical tanks, it says 5-if engine rather than blah, 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 blah. Unfortunately, 5-if engine isn't actually what we wanted to say. We want to say a 5-if engines, which means it's not actually getting overridden properly. Maybe it's not called power. Let's take a quick little look at the prefabs and see whether or not it is just named something else. Oh, I think it's called stats. Yeah, this is actually power. We'll just save that. No, didn't work. Why is it not correctly catching on that there is a power here? Let's pull it back in one more time here. It's called stats again. Didn't I change it to power? I'm like 99% sure that I changed it. Did it not take for some reason? Well, it took this time. Whatever. All right, so now you can see how it says blah, 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 which means our override didn't work, which means we're just going to have to do it a different way. A real quick little change to our subsystem so that the power isn't a... that should work. Oh no, it's a subsystem ability that we need to override. So just go there, go to definition, and this needs to be a getter and a setter. Because you can't override a property with a with a value. You can't. They're two different things. With a getter and a setter, it's completely different field versus a property. Now it should no longer say, it says no desk. That's interesting, because I'm pretty sure that I overrode it. All right, so what we're gonna do is, do I have to tag it as virtual? Is that what I have to do? I think that'll barf, though. Well, let's go ahead and just give it a shot. There's a way to do this, and all I have to do is remember how to do it. We want it to say 5 in engines. There we are. That is correct. All right, so now it's working. Hooray. All you have to do is find the right combination of words. All right, so now what we're going to do is we're going to drop this same subsystem specialty on the other ones where it makes sense, like here. Instead of being on engines, of course, it's going to be on command. And then video screens are a little bit different. We're not going to do that for them. Paste component as new, and then here it's going to be on support. And now when we hit play, we should have one that doesn't have things, and the other 3 should have their own. Yeah. Perfect. So now what we're going to do is we are going to add in the ability for it to read the subsystem that it's the system that it's supposed to be on. So if we look at the subsystem here, we have a couple of sprites. We have the sprite icon, we have the sprite description, and we also have the sprite, there's a secondary sprite that is apparently not being defined. That can't be right. Oh, is it on the UI only? I bet it's only on the UI. Icon versus system. There's a secondary system sprite that we're not actually using. That's good. As long as it doesn't exist yet, we can make it. It's refactoring that's a little dangerous. So if we take a look at the, when we hit play, grind, hit pause, select one of these. If we look into one of these, you can see how there is a power system that is hidden. It's currently just a nothing. There's no sprite attached to it. It's just a white block. That's where the ship subsystems is going to end up mattering. So we call it power system. So that's what we're going to call it here. So public sprite power system get, and we'll just do this exact same thing, except for it's called power system. And then we're going to go over to the subsystem. There it is. And we're going to go ahead and define that public sprite power system. And then we're going to make that a getter and a setter. And basically we're just going to go through all of the subsystems and just return the first one that has a sprite. If s dot system return s dot system. Otherwise return null. Perfect. So the only problem with this is that it's not going to automatically make that icon disappear if there's none. We'll figure that out later. It's not that big a deal. So what we're going to do is we are just going to hit play. And it didn't work. Oh, they're just turned off. That's right. I have to turn them on. Give me a moment. There we go. So you can see that now these systems are set up, but this one here is a white box. So that's the only problem with this approach at the moment. It doesn't understand that a null value shouldn't be a white box, but should instead be a hidden. And there's a couple of ways we can fix that. One of the ways is that we can change it in the UI binder, and another way is that we can add in some special logic. But either way, it's something we can do later. We're not going to worry about it too much. So this is a complicated situation in a lot of ways, because what we're dealing with is something that is actually part of the advanced play of this game. Metacon says hi. Sorry if you said hi a while ago. I've been focusing. See how these are always the same icon twice at the moment? That won't always be the case. There are going to be a lot of times when that icon is going to be different. And basically the icon on the left is the system that you go to when you're on another system. So if you put the chemical tanks onto support, then when you activate the chemical tanks, they'll go to engines, and you'll be revamping them as engines. And that is a completely different function than this. Well, is it? It might not be. We might just be putting it in twice for kicks. Well, we can fix it later. It doesn't really matter. In fact, I don't even think we need the first one, do we? Do we? We might. We need it for a couple of specific ones. That's fine. We'll leave it for now. We'll do it better later. So the next subsystem we're going to want to have, the next subsystem ability is a secondary switch. No. I recommend spelling things right. It's pretty helpful. And this will basically switch between, allows switching between two distinct systems rather than to a specific system. There we go. And basically all we're going to do here is add in the override. Oh wow, it doesn't help you at all. All right, well. Activate, okay. And basically what we're going to do here is, oh, it's a void. What we're going to do here is when this gets activated, that means it's already on the system that the base object considers to be the right system. So what we're going to do is stick it to the other one. And we're just going to go ahead and put in a default debug.log warning. Secondary switch not yet implemented. Because we haven't built any of that logic yet. And we're going to go ahead and override the description just like this. And it's going to be switch between two systems. And we're going to add that to our video screens because they can switch between command and support. And to do that, we're just going to select the support icon and hit play. And now you can see it switches between the two systems. Or it would if we knew how to do that. Matacon says, I have an insight question on your vehicle construction systems. I wonder if there's simply no alternative to voxel construction because devs literally don't have the time and budget to develop those alternatives. That said, Skywonders and Simple Planes seem to be promising alternatives to pure voxels. I haven't played either of those, but given that I can program a whole manufacturing kit that doesn't use voxels and has strong mathematics that are available for, you know, a drag simulation and stuff, I can do that in a day or two and then refine it over the next couple of days. So, I mean, it's like maybe 20 hours of work, and that's roughly the same amount as it would be to build a voxel system. Obviously, the interface is another matter entirely, but that's the same with the voxel systems. I think that the reason that they are so common is simply because everybody has tutorials on how to do them. You know, low-hanging fruit. That said, my main complaint with the voxel systems isn't that they're ugly or anything, it's just that they're hard to create and that they are not capable of doing some of the more interesting kinds of simulations. I need to wash this cup. All right, so now we've got 4 basic subsystems, and what we can do is drop them into our ship as we see fit. Now what we need to do is change the electrical conduits to be something shorter. What do we call it? Power boost? Power conduits? I think that's fine. because we have a hard limit on how long these names are allowed to be. Yeah, that's fine. So now what we need to do is be able to tell the object to do its work. So for that, we're going to just drop the ship in here. No, that's the wrong object. It's actually here. There we go. And this ship is going to be it's going to have the 3 systems inside of it. So there's a lot of ways to set it up so that the systems are automatically populated. Let's go ahead and make a class for that, or a function for that. Public void populate systems. And then we're going to go ahead and make this into an array. And we'll just say systems equals get components in children systems. True. There we go. That should have it work, but this won't get called unless we tell it to call it. Give me a moment to look this up before I answer whatever you just said. So what we're going to do is we're going to tell it to always get called by telling it to runtime initialize on load, runtime initialize on load dot after scene load. We also want it to run during start. I was thinking about how to do this. I think maybe we'll just call it awake. There we are. That's easier. Maticon says, oh no, the Relin says, could you have the selected subsystem highlighted before you put it on a ship? Yeah, I can. I just haven't gotten to polishing the UI yet. So right now when you select the subsystem, it understands that there is a selected subsystem, but it doesn't really understand how to show that down here. And that's just because I haven't programmed it on how to yet. That's something that we're going to be able to do once we get started. It's just it hasn't gotten there quite yet. It's really pretty straightforward. But what we're going to do now is we are going to have it so that when the subsystem gets asked to switch or to activate, we're going to do some checks. So public void activate. I don't know. I don't think is activate reserved? I don't think so. I think lowercase active might be. But activate is what we would like to have happen here. And what we're going to do is when we activate the subsystem, we're going to do a couple of checks. First check, are we on the right system? And so what we're going to do is we are going to get past the system and the ship. So, are we on the right system? Well, we can check that by just comparing it. So is our system dot icon, if our system dot icon does not equal the system icon, then that's the wrong system. And so what we're going to do is we're going to say our system dot remove this. Here's the only problem with this. The UI elements do not understand what the fuck is going on. We're going to have to add in a method to have the UI elements try and track down what's happened and how to fix it. So we'll do that in a moment here. Our system.remove this, and then we're going to want to ship.find system system.add this. So over here on the ship, we're going to be able to take a find system, public ship system, find system, sprite system. For each ship system s in systems, if s.icon equals system, return s. Return null. We're going to go back over here into the subsystem, and we're going to actually make sure that we can find it first. If Ship system target equals ship.find system. If target else debug.log warning no system of that type on this ship. No system of type system.name on this ship. Now we've got an underlined set of garbage here because it's capitalized. There we are. All right, so now what we've got is a setup where if we're not in the right place, we will go ahead and add ourselves to the right system. But we don't currently have any way for the UI to know that the subsystem has been changed. So we're going to go ahead and add we've got a subsystem event here. And what we're going to also have is, I don't even think there is any subsystem event on I think we're not actually using that. We do, however, need a basic event. So we'll just go ahead and put that down at the bottom here. Unity event on changed. So down here, we're just going to go ahead and say onChanged.invoke. So when we have a subsystem UI like this, we're going to want to make sure that we sign up for the changed event, which will allow us to make sure that we exist. So public void start. If not subsystem, debug.log warning, no subsystem on subsystem UI plus name. Else subsystem dot on change dot add listener update visuals. Public void update visuals. So here's where we're going to make sure that the ship's subsystem is still on the same system that we're on. So that's not too hard. We just have to look at our parent as compared to its parent. Now we should have a list. We actually keep a list directly to the subsystem rather than the subsystem UI. Wait, no, that's correct. Where's the system? System UI. Here it is, parent. So when we update the visuals, we're going to check if parent.sprite, parent.icon, yeah. If parent.icon does not equal subsystem.icon, no wait, subsystem.system. No wait, the subsystem has no fucking idea where it is. I already made that point abundantly clear. So what we need to do is we actually need to track it down in the ship or pass it via an argument. Let's go ahead and pass it via an argument just for the sake of having it work. So here's the ship system. We're going to go ahead and add in a new event. Public class ship system event, Unity event, ship system. And that's going to be system.serializable. And then what we're going to have what we're going to do is we're going to throw that when we move to a different system. So ship subsystem, I'm all out of order here. Let's see if I can get these things even vaguely in order. There we are. So what we're going to have this subsystem able to do is fire off a system event. So down here in the on changed, we're actually going to have this be public system event, or ship system event on reparented. Because it's something that happens a lot. So let's go ahead and have it be well thought out. There we are. So the ship subsystem UI, there we go. So the ship subsystem UI is going to be something where it's going to take on reparented, it's going to take a ship system. There we go. And we'll just change the name here to reparent. Shaboom, boom, boom. Boomity, boom, boom, boom. There we are. So what we're going to do is we're going to move ourselves to the new parent for this particular system. Now the problem is that we are a UI object. We're UI, and the new system is not. We need to find the new system UI counterpart. So we're going to find a ship system UI that is based on our same parent object. The only problem is our parent object has no cap. This ship edit canvas doesn't have anything at the base. It has a ship editor at the base, but we might not be using the ship editor at all times. So we're going to want to have a ship UI. We'll just drop that onto the same setup here. It's going to be on the systems section rather than the whole thing, because these potential subsystems are not part of the ship. So from there, what we can do is we can open that up, and we can have it have a list of system UIs. So this is a good time for us to implement the auto-populate, and that's what we're going to do. So public transform content, public ship system UI UI prefab, public transform, what did I call it for the subsystems? Let's look it up. Container, content target and subsystem container, yeah. System container. How would you call it? Ship. Ship. And that's not going to work unless we add in the ship. There we go. Ship. All right, so now that we've got our ship, what we can do is we can add in a list. Matacon says, so about ship design and voxel systems, what's stopping designers from implementing multi-directional thrusters in the first place? Computational complexity issue or a byproduct of low-hanging fruit? You know, I don't know. I've made a couple of... First off, the multi-directional thrusters are a separate issue from the voxel ship systems. They crop up in the same places, but fundamentally I've had the same multi-directional issues in other sorts of games where I'm defining a mathematical hull, but I need the thrusters to be multi-directional. And I've done a lot of that, and it is a little bit finicky to get it to work. It's not terribly hard, but it is something that is an effort. And I imagine that a lot of people start off thinking that they're going to want to put in like vectored thrusts and stuff and then just say, and give up on it. I got these trash bags, and I accidentally brought the Febreze type, and holy shit, they stink. Give me a moment. God, you stink. I bought the industrial size pack too. I'm only going to be able to use them in like the bathroom maybe. Yuck. What a mistake. I never even thought that there would be scented trash bags. All right, so we're going to get a list of subsystem UIs, ship system UIs. There it is. And these are going to be active, or no, active is reserved. They're going to be, let's call it list. So what we're going to do here is we are going to initialize all of this stuff. To do that, we're going to just go through all of the ship systems and create the ship system UIs for it. Put it in its own function, public void populate. First thing we're going to do is we're going to delete everything in content. For each transform t in, actually, no, yeah, that's fine, content. Destroy t.gameObject. And then we're going to clear our list. Oh, no, wait, we can just do it for the list. My bad. While, no, we'll just do it for each. For each list, ship system UI, L in list, destroy L.gameObject. List.clear. Now what? I want to... Sorry, it just smells so bad. It's distracting. All right, so we're going to go through all of our ship systems. For each ship system, S in ship.systems. Ship system UI, UI equals ship system UI dot, nope, dot instantiate. And then we're going to instantiate the prefab. We're going to put it inside of our content. Perfect. Now we're just going to set that up, UI.system. Yeah, UI.system equals S. It's not called prefab. I called it UI prefab. That's fine. And then we add that to our list. So list.add UI. And I think that's all we need. That should literally be everything that we need to make it work. Now I just have to do a little bit of grunt work to actually set these up. So we're going to rename support into system UI. And then we're going to add in the one thing that's not here, which is an icon. No, not inside of the text box. Icon. Did I call it an icon? Let's just do a double check here. Icon, yeah. So this icon, I'm going to go ahead and just make it black so I can see it, and then we're going to move it into the right spot. I think we're just going to put it off on the left or on the right. On the left. We'll make it on the left here. We'll anchor it to the left, and we will make it a 32 by 32, which I believe is the size of the sprites in question. 60 by 60. So we'll make it 30 by 30. And we'll change it back to being white. Boom. And then we're going to move the description over a little bit. There we go. So with that in mind, this system UI can be saved and then deleted. And then what we'll do is we will start to add that to the setup here. There you go. Now when I hit play, didn't work. No errors either. Did the ship not calculate fast enough? That's in awake, so that should work fine. Debug.log name ship has systems.count.length systems. Let's make sure everything is working. That's probably just something I missed. Something not wired in properly. Pufferfish has 3 systems. So why aren't... Oh, we didn't tell it to call it. So here's ship UI, start, populate. It's always the wiring that breaks in game development. I mean, there are still like actual bugs, but I always find wiring errors. There we are. So here you can see that we've got a whole bunch of things called System UI clone, which is obviously going to have to change because that's dumb. There we go. So now that we've got these systems set up, we can start to drop things onto them and see whether or not it works. Seems to. Oh, misclicked. We're going to have to modify the camera a little bit, I think, but that's okay. We'll deal with that later. For now, what we've got is a fully functional set of objects. The only problem is that at the moment, we can't tell it to trigger the abilities on these subsystems because they don't actually understand what's going on. So what we're going to do is we're going to create a specialty on the ship system, on this, which allows us to right-click on the ship system and tell it to do something. Specifically, it's going to tell it to trigger all of its subsystems. So we'll go into it. Public void debug trigger subsystems. And that's going to be a menu item. And so what we're going to do is we are just going to go through all of our subsystems and trigger them. Call this debug activate because it's activate, not trigger. Now activate takes a couple of arguments. Obviously it takes us, but it also takes the ship. Currently we're not keeping track of the ship, so we're going to go ahead and do that. Public ship, ship.ship, ship. Twice. This one's a getter and a setter. Get. If not ship, ship equals get component in parent ship dot ship. Return ship. Perfect. So now what we're going to do is, why is it barfing? Oh, we're actually in the namespace, so we don't have to do that. There we are. So now down here, what we're going to do is we're going to pass it the ship and us. And this is a for each. Fun designer idea, Metacon says. Voxel firearms doesn't have to be intensely complicated. I wonder where that could lead. So voxel firearms makes more sense than any of the other voxel things we've seen because firearms are all about shooting straight. So voxels inherently make sense for things that are aggressively linear like that. So I think that would be kind of fun. The only problem is that fundamentally firearm, the mechanics of the firearm are pretty basic. So it's like if you're going to make a voxel pistol, the complexity isn't in the bullet, it's in how the bullet gets loaded into the chamber. And that's not really something that feels like it would be a lot of fun to design, because it feels like once you design it once, it just works. But if you were going to make it something a little more exotic, you could probably work that out. Because the whole point here is that you have to have a lot of variation in what you're designing and a lot of different approaches that all work. And with firearms, that's pretty much a solved situation. At least I think so. So let's hit play and let's try some activating and see whether or not it all works. So what we're going to do is we're going to drop the power conduits on the engines, and then we are going to tell the engines to activate all their subsystems. And what you can see here is it says, blah! So that makes sense. And what happened is it correctly moved it, but then it crashed instead of properly moving the UI element. So for each, this part's not working. So what we're going to have to do instead is cache all of the values so that we can go over them even if they change. So we're going to create our own list. Can I pass it a list? It can. So we'll just pass it subsystems. That way I won't barf. All right, now let's try that again. Power conduits on command, and then we'll tell command to trigger. All right, so you can see how the UI elements worked, but I mean the 3D elements worked, but the UI elements didn't. So we're going to start to track down where the UI elements are screwed up, and that's going to be over here in the ship subsystem UI. We're going to want to, oh, we forgot to actually implement it. That's your fault. So we're just going to go ahead and say ship. Do we have the ship access? We don't have. So the subsystem UI has a system UI parent, but it also has a ship UI parent. So ship UI equals get component in parent ship UI. And so what we're going to need to do is find out the version of the UI for that. So ship system UI equals ship UI dot get system UI new system. However, in order for us to do that, we're going to have to implement it. We haven't implemented it yet. So public void ship system UI ship system. For each, well, it's not a void, idiot. For each ship system UI s in list, if s.system equals system, return s, return null. There we are. So now we can just ask it for our ship system UI, and that'll tell us exactly how to do it. Now the only problem is that the ship system UI over here, subsystem has wandered a little bit. Don't need this anymore. The ship system UI is set up specifically to add and remove subsystems at a core level, which also involves modifying the system, as you can see. So bool deep equals true, and we're going to add that in both. And we're going to go ahead and add in some comments. Modify ship if true, otherwise UI only. If deep, And so over here, when we are actually going to be modifying, reparenting, what we're going to have it do is it not called get system UI? Is it called the system UI? Yeah, that's fine. What we're going to have it do is it's going to be doing it shallow instead. So system UI.add subsystem, and then we're going to pass it the system and false. And then we're going to remove it from ourselves. Is it not called... Hold on. What's going on? Oh, this is... Idiot. I was getting all myself confused even after adding in all the UI stuff. So basically what we're going to do is we're going to reparent it. So we're going to delete it from our current system. So we currently have a system UI. Is it called system UI? Ship system UI, parent. There we go. Let's go ahead and see whether this works. I'm gonna open the door. It stinks so bad. I was like, maybe it'll be just like a gentle scent. No, no, it's not. It smells like someone emptied an entire can of Febreze up my nose. Wow. Whew. What a misadventure. All right, so let's give it a shot. We're going to add the chemical tanks to the command and then tell the command to activate. And you can see how it moved them back to the engines. Perfect. So, of course, now if we tell the engines to activate, they're not going to do anything because we haven't implemented any sort of activity for the chemical tanks to actually perform. One of the things we're going to want to do is we are going to want to make it so that the subsystems understand whether they have something they are able to activate. So we're going to have to add in a new Boolean. Oh, we don't need this anymore. Public bool can activate. But can activate, it's going to have to be past a ship system. If, so if current parent dot icon does not equal system, return true. Return false. So what we're going to do is for each subsystem ability s in abilities, if s dot can activate current parent, return true. Of course, right now there is no such thing as can activate, so we're going to have to actually go there. Boom. Public virtual bool can activate. This is supposed to be a ship. And what we're going to do is we are going to have this activate with a specific system. System, ship system, system. This is not in the right namespace. Namespace, subsystem. Yeah, Matacon's talking about why it might stink so bad, and I think that they actually just made the trash bag out of like dried Febreze. If we're just gonna return false. Here. Why is ship system barfing? Oh, using ship. There you go. All right, so now what we've got is, it's fine. So now what we've got is the ability to check whether or not a subsystem ability can be activated, and our ship system can determine whether or not it can be activated. Also down here, we're going to activate it. Hooray! Right now we are telling it to activate a ship. We're actually going to tell it to activate a ship system. Because we can track down the ship from the ship system. There's no big deal there. So that's a little bit easier on us. Go over to the subsystem, and we'll go ahead and say for each subsystem ability A in abilities, if A.can activate this, no, system, no, our system, A.activate our system. Exciting stuff, as you can see. Perfect. No, not perfect. Total botch job. Now it's perfect. So now what we've got is a setup where when we activate something, if we can't reparent it, then we reactivate it. There we are. No, wait, because that'll end up toggling it. I don't know. We'll figure that out later. So now what we've got is the ability to end up reusing our abilities. So what we're going to have is for one of our subsystem abilities, we are going to go over to the switcher. There it is. Here it is with activate, and it's like game object ship. It's actually going to be ship system, right? Yeah. We're also going to want public override bool. You going to tell me anything? No, fuck you. Are we not using system? Here we just say if, we just say true. There. So what we're going to have here is when we activate from a ship system, we're going to want to transfer it to the target instead of where we are right now. So we're just going to go ahead and have it do the exact same thing that it actually does with the subsystems. Here, this. Now in order to get the ship, we have to get it. So ship.ship equals there, equals system.ship. Perfect. And then here we just say, oh, ship.ship ship. Target equals ship.findSystem, and then we're going to pass it our system icon, which is not called system, is it? It's called something else. Oh, or unless it's called this.system? Yeah, it's called this.system. That's fine. We're passing around variables that are named the same thing as a class variable. Well, whatever. So what we're going to have it happen here is if we can find it, we're going to want to move it. So it's going to be system.remove this. Except we're actually part of a parent object. So subsystem s equals, we're going to have it. Gonna have it pass us enough information for us to actually do the job we were trying to do here. Why is it not allowing me to pass? Oh, it's yeah, whatever, one of those. So then we say subsystem.onReparent.invoke, and then we pass it the target. That should work. So what we're going to need to do is we're going to need to change the main switching subsystem ability here to have it get past a subsystem. We're going to go ahead and go back over into our subsystem and pass it this. There we are. So that should work. We should now be able to activate them, except for we are barfing, and that's because our custom values are barfed. We'll work with this later. Wait. Sorry, I'm thinking about what this actually means. Because currently we have a subsystem where we have a subsystem specialty here, which the whole point of this is that it'll change the value when it's on the correct object. But we don't actually implement that at any point. So what we're going to want to have happen here is we're going to want to have a special... There are a couple of things that we are going to need to have happen. Public bool. This is going to have to be on the main subsystem ability. affect base value equals false. And here in subsystem specialty, it's going to be true. It's a can activate, but it's... So the problem is that the activation phase is different. So I guess what we need is an enum, public enum activation phase. Value none, value, or mission. There we go. So when we say can activate, we're actually only going to be activating on the phase that we're supposed to activate. The problem is that this returns a void rather than an integer, so we can't really do that, but what we can do is we can activate it and then steal the value out of it. The only problem is that the value is something we have here, so let's just make it return an int. Override public int activate. And what we're going to do is we're going to return value. And then we're going to have override public bool can activate. And we're just going to test and see whether it's the right system. If system.icon equals this.system, or return that, I guess. So over here on the problem is that the specialty system should always have a different default value, but whatever, we'll leave it. We'll leave it. It's fine. I just have to remember it, and that's not a good idea. Anyway, what we're looking for here is the subsystem value. Here it is. So we're going to go through for each subsystem ability A in abilities. If a.phase equals activation phase dot value, if a.can activate, we don't know our ship system, do we? We don't. Value doesn't understand what system we're looking for, so this is going to have to be if can activate system, then we want to activate it. And then we want to return a.value. Except for it's not a.value, is it? No, just return a.activate. And over here on activate, we're just going to return the value. Yeah, perfect. So the only problem with that is we've totally invalidated one of the core things we were doing, and we have to fix that. So what we've done is we've made it so that what used to be a lowercase v value is now a capital V value. And the real issue with that is that it's here on the subsystem UI. We've got this. This no longer exists. So what we have to do is we have to be able to pass it the ship system that it's on. So this is actually going to get a little bit more complicated because it actually contains a reference that the object doesn't understand. So if there is no subsystem, return 0. Otherwise, return subsystem.value, capital V, and we have to pass it the ship system. Well, the ship system is our parent.system. There we are. So even though the ship subsystem is a pure data object with no idea as to whether or not it is where it is, the UI has that knowledge, and so we're just injecting it here. The Relin says, if I hear the word system one more time, I swear to God. Yeah, I wasn't really thinking straight when I called them subsystems first, and then I said, well, what's the subsystem part of? It's part of the system. So now I've got systems everywhere. Unexpected symbol barf. Oh, there's no get. It's a function now. So here's where we're getting the values out of it. And obviously we have to actually use the new capital value, but we can just pass it ourselves because this is the ship system in question. Perfect. Let's go ahead and try it out. Now, when we add engines, add chemical tanks to the, oh, it barfed. Return subsystem value parent.system. It looks like we might not be setting parent correctly. Oh, we are. So the problem was that it was crashing before the first frame had started. You can see how we got lots of negative ones here. This means that the parent's not being set correctly. I was right the first time. When we're setting up our ship subsystem UI, we're adding it to various objects, but we're forgetting to add the system UI to the subsystem. So here is where we add our subsystems. So we say subsystem UI.parent equals this. So then here in the subsystem UI, why are we not seeing a parent? Hold on, this is all screwed up. If there is if there's not a subsystem, then return null. Otherwise, return subsystem.parent. Subsystem is the subsystem data class. Why would it have any idea what the parent is? How did this ever work? It never did. That's just what it is. So when we're returning the subsystem parent, why would the subsystem parent be a... Wow. That's just wrong. That was an error I made when I was separating the classes into data and visual. Here we are. So... there we are. And we're just going to go ahead and return this. I think that'll work. Let's try it. Nope, still -1. Well, let's select one of these and see what it has to say for itself. So the parent is none, so it's not getting set. Oh, it's actually not on a system. Of course it's not. Idiot. Okay. This is not an error. It's just me being stupid. When it's like just randomly piled in the back of the junkyard, it's not on a subsystem. So when that happens, we just want to return value. So we're going to go back over here into the subsystem. There it is. And when we try and get the value, we're going to go ahead and say if system equals null, return base value. Over here in the subsystem UI, what we do is when we are checking for our value, we say if there's no subsystem, return 0. If there's no parent, return -1. We're actually going to say if there's no parent, then just return system value null. There we go. And now we should see the correct values. Perfect. All right, so now if we drop the chemical tanks on the engines, it's still a 3. US. All right, so let's go ahead and see what's up with that. We're going to go ahead and add in some debugging. Oh, I know what the problem is. The activation phase is wrong. I already said I'd have to remember to fix the activation phase. None is the wrong value to default to. Only problem is that these are now all incorrect. We'll just set them up. No, wait. Those are all subsystem specialties. Those are all values. This one's the only one that's a mission. There we are. So now we hit play. Chemical tanks on the engines, 5. Da, 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 da. And then you drop it back. 3, 5. We are looking good. 3. Support, and then we drop it over from support. Activate, 5. Oh, it works. All right, shall we test and see whether or not the flip-floppy works? So let's add our video screens to our engines, and then we'll have our engines activate. And the video screens flip to command, and then when we activate command, they should flip to support. Yeah, look at that. Now, the only issue with this at the moment is that when we are doing this, they are rejiggering the ship. So the visuals of the ship change. That's actually not going to happen once we're in flight mode. The compounders will be locked down and they just won't respond. So we'll do that later. But basically, if you do start switching things around, your ship isn't going to radically change shape. But that's good. That's great. We finished everything I wanted to do today. Next time, which should be Wednesday, we will be making crew members, maybe. Or maybe we'll be making mission systems. I haven't decided yet. One thing we're definitely going to be making is a new trip to get new trash bags. So I'll see you later. I'll hang around chat for a couple more minutes and answer questions if you've got any. I'm going to go back to playing Stormworks. Gotta go back to playing Stormworks after I stop this. So have fun.